Hey everybody, remember at the end of the last video we were working on getting the best line to go through our dots, and we said the best line would be the one that minimized the sum total of the errors, which are called residuals. The problem is some of the errors are positive and some of them are negative, so when you add them up, some of them are going to be canceling each other out, and we don't want that. So we said that we were going to square them to make them all positive and work with that. And so we're going to define the best line to be what's called the least squares regression line. What is that? Well, the least squares regression line is the line that minimizes the totality, in other words, the sum of the squared errors. So we're squaring them basically to make everything positive. So square them to make them positive, add them up. You want the smallest total there. We will use technology to do that. It's extremely tedious to do by hand. So using technology, we will find that the least squares regression line for this particular golf example happens to be y hat, and so it's traditional to use a hat on the y to indicate that the y value isn't an actual y value, it's the y value on the least squares regression line. Anyway, that line is 3.1661x minus 55.7966. So, and here's a visual, what it looks like. Okay, that line there, that is our least squares regression line. Let's use this line, this model, to predict how far the golf ball will travel if x equals 103. So let's see, I'm putting, where's my equation? Okay, here's the equation. Okay, so I'm going to put 103 into this equation for x. So y hat for this x value is 3.1661 times 103 minus 55.7966. Crunch, crunch, crunch the numbers, and we'll get 270.3 yards. Okay, so the residual or error this time is the observed value, which remember was for x equals 103, the observed value was 274. You can just glance up a little higher on the paper, see that in the previous picture. 274 minus this model, this least squares regression line model, predicts a y value of 270.3. The difference between the observed value and the prediction is 3.7 yards. Couple of notes about this. Because the residual is positive, that tells us the observed value of 274 yards. Well, it's above that least squares regression line, so it's above average for a swing speed of 103 miles per hour. Second, the least squares regression line will not necessarily go through any of the data points on the scatter graph. And you can see that if you look closely at this line, it doesn't actually go through any of the data points. What it will go through, though, is x bar, y bar. In other words, it'll go through the point represented by the average x value or mean x value and the mean or average y value. One other thing I want to mention is that it so happens that the residual we found for 103 using our least squares regression line. So the residual for 103, that's going to be this distance, which we found to be 3.7 yards. that happens to be less than the residual for x value 103 in our hand-drawn line, which is not the least squares regression line. So for that line that we just kind of eyeballed and drew in, the residual is 4.7. This is 3.7. I just want to point out that it would not necessarily be true that the residual for the least squares regression line would have to be less than the residual at that point for a line that's not as good. What the least squares regression line gives you is the sum totality of all the residuals is minimized. So in general they'll be smaller, but some of them could actually be bigger. That is probably a good stopping point. So I'm going to leave it there, and we will come back then and do some interpretation on what the numbers in our linear equation mean. So I'll see you in the next video for that.